This is the solution video for section 5.3, problem number 4. A person holds uh, a person flying a kite holds the string 5 feet above ground level, and the string is paid out at a rate of 2 feet per second as the kite moves horizontally at an altitude of 105 feet. Assume there is no sag in the string. Find the rate at which the kite is moving when 125 feet of string has been paid out. All right, so you've got this person standing here, all right, holding a string to a kite. All right, so kite is up here somewhere, right? All right, and all right, so here's our kite, all right, and the kite is being blown horizontally, right? Now, what you want to realize is that this just makes up a right triangle, of course, right? Now, it's flying horizontally, right? So horizontal, right, just would be parallel to the ground. Now, you're told that the kite is being held 5 feet off of the ground, right? But it's also, you're told it's at an altitude of 105 feet. So that means the altitude is 100 feet above the height of the person's hand, right? Now, that is not changing because the kite is flying horizontally. All right. But what is changing? All right. Well, the distance horizontally that the kite is from the person holding the kite. So let's call that x, right? And that is changing, right? And so we're going to call that dx dt, right? That is a positive value, right? Now it says find the rate at which the kite is moving, right? So that's actually what we want to know, the rate at which x is changing, all right? Now, we also have the string here, this diagonal, right? So let's call that S, right? Now that is changing, right? And so that is a ds dt, right? And that is a positive value. Now, specifically, you're told that the string is being paid out at a rate of 2 feet per second. And so ds dt is 2 feet per second. And remember, it is positive because S, the length of the string, is getting longer. All right. All right, so now we've related all these variables. Now, remember, 100, we do not put a variable there because that is a fixed value, right? The height uh, of the kite is not changing, right? So that is not a variable. All right. All right, so now what do we want to find? Well, it says find the rate at which the kite is moving, right? So we already said that that is dx dt when what is true? Well, when 125 feet of string has been paid out. So when s is 125. All right, and so how are the variables related? Well, this is just a right triangle, so they're related by the Pythagorean theorem. So x squared plus 100 squared equals s squared. All right. And so now, all right, we are ready to take the derivative. All right, so derivative of x would be 2x dx dt plus, well, derivative of 100 squared. Remember, this is just a constant, right? So it's 0, right? The derivative is 0. Derivative of s squared, so 2s ds dt. All right, and so it said find dx dt when s is 125, right? So I know s is 125. I know ds dt is 2, but I don't know x. So we actually have to go over here and we have to find x, right? So x squared plus 100 squared equals 125 squared, right? So you could use the Pythagorean theorem, right, and solve for this. And the fact is that x would be 75 when you solve. How do you know? Well, how do I know off the top of my head? Well, this would be a 3, 4, 5 triangle, right? Because if you have a 3, 4, 5, right, and you multiply everything by 25, right, you would get 75, 100, and 125. Excuse me. All right. So x is 75. So now I'm going to plug in the values that I know. So 75 dx dt is what we want to know equals 2 times s. S was 125. And then ds dt is 2. All right. And so now I'm going to solve for dx dt. And so I get 2 times 125 times 2, all divided by 2 times 75. All right. And so now I'm going to reduce a little. 2's reduced. 125 and 75, they're both divisible by 25, right? So this becomes 5 and this becomes 3. And so I end up with 10 thirds, right? So 10 thirds is the rate at which the kite is moving horizontally, right? So 10 thirds of a foot per second. Remember, it's feet per second, not like square feet or something like that, because remember, this is a linear measurement, right? We're just measuring a distance and the rate at which it's changing. All right. So